The number of births in a particular hospital occur on an average of 2.6 per day. Let the random variable x equal the number of births. What is the probability that no births will occur today? So the question is, what's the probability that 0 births will occur in an interval of time, 1 day? So we're looking at trying to find the probability of a certain number of occurrences in an interval. So this is going to be a Poisson probability. I'm going to use the function x. The number of occurrences is 0. This is an interval of time of 1 day, so mu is actually given as 2.6. So I'll take that to the 0 power e to the minus 2.6 into the formula, and then 0 factorial. I'm going to plug everything into my calculator and calculate that as 0.0743, which is approximately 7.4%. So my answer there for part A is 7.4%. The probability that no births will occur in 1 day at the hospital would be about a 7.4% chance of that happening. B. The question is, what is the probability that 4 births will occur in that day, today? That's exactly 4. So probability of 4 would be f of 4. So that's still a day, so my mu hasn't changed, 2.6, but I will raise it to the 4th power, e to the minus 2.6 still, and then over 4 factorial. Putting all that in my calculator, I get 0.1414, which is approximately 14.1%. So 14.1% is the probability that there will be exactly 4 births in any given day at that hospital. 14.1% chance. Now that's saying exactly 4, not more than 4, less than 4, or 4 or more, or 4 or less. It's exactly 4. So it's a 14.1% chance. Okay, C. What is the probability that 0 births will occur in the next 12 hours? Okay, now on this one, mu has changed. We know that mu is given for a day, 2.6 per day. So what would mu be for 12 hours? If they're averaging 2.6 births per day, then that would be 1.3 births on average every 12 hours, right? So I've got to change my mu in this one because the time interval has changed. And I want to know the probability of exactly 0, or in other words, no births in 12 hours. So I'm going to put the 1.3 to the 0, e to the minus 1.3 over 0 factorial. So again, 1.3 to the 0 is 1, and 0 factorial is 1. So this is just e to the negative 1.3. So this would be 0.2725, which I'm going to write is approximately 27.3% probability that in the next 12 hours, or in any given interval of 12 hours, there will be no births. The probability of no births in a 12-hour period at this hospital will be 27.3%. Okay, D. D says, what is the probability that at least 1 birth will occur in the next 12 hours? Notice that we're still with the 12 hours, so mu is 1.3. And it says at least 1. So at least 1 would be f of 1 plus f of 2 plus f of 3 plus on and on and on. Now, if I take, the other possibility is no births, so if I would add these all up, this would equal 1. So to get what I want, to get at least 1, I'm going to take 1 subtract f of 0. And 1 subtract f of 0, we've already calculated f sub 0. And we got to make sure we calculated f of 0 twice. One was for the whole day at 2.6 bursts per day, and the other one was for 1.3. So we're going to make sure there that this is still a 12-hour period, so we're going to use the value we get in the 1.3, which is 0.2725. So if I subtract those, I get 0.7275, or approximately 72.8% probability that in a 12-hour period at that hospital there's at least 1 birth. There's a 72.8% probability of that. Okay, for our last problem, E, it says what is the probability that 1 birth will occur in the next 4 hours? Okay, our interval has changed again. So let's see. Well, the last one was kind of easy. I know there is 2.6 births every day, so that's 24 hours. That's 2.6 births per 24 hours. And I'm looking for the average number in 4 hours. So I can actually just set up a proportion here and then calculate mu equal to, remember the cross product, 2.6 times 4 divided by the 24. And I actually get a 0.433333 value for mu. So in E, my mu value has changed. So I want the probability of exactly 1 birth in 4 hours. I'm going to use 0.4, and that 3 with a bar on it is, when you put that in your calculator, put it in as 0.4333. Put a few 3's on the end of that just to keep it accurate. And we take that to the first power, and then e to the minus 0.433333, and then divide the whole thing by 1 factorial. So if I do that, I get 0.2809, which is approximately 28.1%. So what's the probability that there is exactly 1 birth in the next 4 hours? There's a 28.1% probability of that occurring.